Today we talked about titrations. If you are watching this, probably because you were gone to some extracurricular activity, maybe you're sick. So anyway, we're going to talk about acid base and titrations, and when we do this in lab, this will hopefully make a lot more sense to you. What a titration is basically you take an acid and a base, you put them together. One of them you do not know the concentration of, you don't know the molarity. One of them you do. If you'll notice in this picture here, we're going to be dealing with a burette. And in the burette you put the thing that you do know the concentration of, in this case it's the base, and you slowly add it into something that you don't know the concentration of. It will change the color, and through the magic of math you actually can find out the concentration of that. And that's basically all a titration is. So what we did, we talked about an acid-base reaction. Every time you have an acid and a base put together, it always makes salt water. And so I gave them an example. If you have potassium hydroxide and hydrochloric acid, potassium hydroxide is KOH. It would react with hydrochloric acid, and that's just a double displacement reaction, and one of the things it's going to make is going to be water, because the hydrogen and hydroxide come together to make water. And then the potassium, which is a +1, is going to combine with the chlorine. So the potassium from this guy and the chlorine from this guy is going to come together and make potassium chloride. And this is known as your salt. And what a salt is the product of an acid-base reaction where the anion, which is the positive part, comes from the base, and the cation part comes from the base. The positive part, cation, comes from the base, and the anion, the negative part, comes from the acid, which is what the definition of a salt is. It'll be on our next slide. So the cation comes from the base, and the anion comes from our acid, and that makes our salt. So this is not normal NaCl salt, but NaCl salt can be made from sodium hydroxide and hydrochloric acid. So here's some definitions, and I told them that you would need the definitions, so I'm just going to click through them. They're on the PowerPoint, so you can get them from the PowerPoint, or you can slow down, but this is what I just said. The product of an acid base, the cation comes from the base, and the anion comes from the acid. Titration is a lab procedure used to determine the unknown concentration using the known of either. And we titrate to something called equivalence point. And the key part of this definition is that it is equal moles. The moles of your acid and your base are equal to one another. And you will need to know these three definitions for your quiz. On equivalence point, if you leave out the fact that the moles are equal, then I will mark it wrong. So you can get that from the PowerPoint. Here's our formula for titration. It's the molarity of our acid times the volume of our acid divided by the coefficient of our acid. That's going to equal the molarity of our base times the volume of our base divided by the coefficient of our base. And this should look very similar. It's just like a dilution problem, which is the MV equals MV. The difference is we got coefficients for acid and base there. And so we have one sample problem that we did together in class on this. It says a 50 milliliter sample of potassium hydroxide is titrated with a 1.605 molar solution of sulfuric acid if the titration requires 24.09 milliliters of the acid solution to reach equivalence point. What is the molarity of the base? And so this is very, very simple to do. You're going to have your first thing you've got to do is write your balanced equation. You've got H2SO4, which is sulfuric acid, reacting with potassium hydroxide. Again, it's going to make salt water. The salt that it makes here is actually potassium sulfate, and it makes water. And then you need to balance the equation. And to balance this one, you would put a 2 here and a 2 here, and there's my nice balanced equation, which is the first step that you need to do when doing these problems. And then you're basically going to be filling in this formula. Here I'm trying to do a dilution problem. The molarity of the acid times the volume of the acid, this time it's going to be divided by the coefficient of our acid, equals the molarity of our base times the volume of our base divided by the coefficient of our base. So then as we read the problem, let me scoot this up a little, you're going to be filling in information. I'm trying to get it where you can see it, but it's not going to work real well. So we'll just have to scroll. I'm just going to be filling this in as we read. The first sentence says that you had 50 milliliters of potassium hydroxide. Potassium hydroxide is our base, so we're going to put that on the base side, which is this side. 50 milliliter is a volume, so we're going to put 50 milliliters right there. And then it says is titrated with a 1.605 molar solution of sulfuric acid. That's the molarity. Molarity needs to have the chemical symbol with it. And it says we need 24.09 milliliters of our acid, so that's going to be our acid. It wants to know what is the molarity of our base. So there's our question mark. Looking very much like a dilution. The only difference now is we're going to be using coefficients, and our coefficients in front of this guy so happens to be a 1, and that is in front of our acid is a 1. And the coefficient in front of our base here is a 2. You don't need your salt or the water. We need to write that out for the equation will balance. And then basically now we're just solving. You can solve however you want. You could cross multiply and take 1.605 times 24.09 times 2 and get that number. And I think it's 77 something. I've forgotten what it was. 1.605 times 24.09 times 2 divided by 50. Alright, so you're going to get, basically this is x, so you get like 50x equals 77.3289, and then and again, however you want to do your algebra is fine. You don't have to show all this algebra steps, but I would like you to get the right answer. The correct answer is 1.55, because we had 3 sig digs up above. We were trying to solve for sodium hydroxide molarity, so you would get potassium hydroxide molarity, so you get molarity potassium hydroxide. And that is as hard as they get. You just got algebra. You could take your answer that you get, the unrounded one, plug it back in and see if it matches. So there should not be any algebra issues. You'll take that half a second and check your algebra. Okay, the assignment that they had was from something called the Little Green Book. And you'll need, if you have not already come by, you need to come by and pick up the Little Green Book. It's page 229, 221. Make sure that you get the additional practice, which is at the very bottom of the page, starting on 219. Do not try to do the practice. You're doing the additional practice, 219 through 221. And then I had to give them the formula for citric acid because it's one that you'll need on number 9. Citrate is C6H5O7. He actually has a -3 charge. That's why you see through here. The book will use the terms monoprotic sometimes on you. It'll say diprotic, and it'll say triprotic. All that means is trying to help you write the formula. A monoprotic only has 1 hydrogen that'll come off. Diprotic would be like sulfuric acid that has 2. And then triprotic citric acid, which we find in like lemons and things, will have 3. That's a triprotic acid. So those are very easy terms to understand: monoprotic, diprotic, and triprotic. That is all of the lesson. It was super, super easy. So you'll need to come again to pick up that Little Green Book for you'll be able to do this homework. Have a great